was nice. Yeah, all right. I'm liking all the OpenBMC interest here. All right, so as Norm said, my name's Andrew Geissler. I work very closely with Brad at IBM. I've been working on OpenBMC for a while, and today I'm going to take you through kind of the customer level functions that you can get with OpenBMC. So not necessarily a feature, but one of the things that I think is really awesome about OpenBMC, right, is it's product ready, right? So we've got multiple companies that are shipping OpenBMC to multiple data centers throughout the world. I know at IBM we've definitely shipped a bunch of systems with it. And you know, if OpenBMC had been in the state that it's in now 2 years ago when we first started building our system, I would have been ecstatic, but it wasn't. But it is now, and so we've upstreamed all the code and all the fixes that we've done. They're out there in master. On this screen, other than my ecstatic rocket launching and fireworks pictures here, just because I was so excited about this, I've got at the top there a picture of the state manager that runs in BMC, in the OpenBMC, just showing that you've got a ready state for your BMC, you know, the chassis power's on, and the host is up and running. Below that, it's got a screenshot of our ambient sensor. We've got a deep collection of sensors within OpenBMC. The bottom there is just an IPMI command. The bottom right is the event log and error logging. And really the point of all these, and I'll talk a little bit more in detail about some of these later, but you know, we've got all the building blocks that you need to ship a BMC system. One of the key data points and design points for us from the beginning was, you know, an abstraction between the business logic for your code and the data that drives it, right? Because we knew that it wasn't going to OpenBMC wasn't just going to be running in a server. It could be running in a router. It could be running in a network switch. It could be running, you know, on a Raspberry Pi. And so there's a big, throughout all of the repositories under OpenBMC, there's a big focus on your business logic in your code, and then the data that drives that. We got really enamored with YAML for a while, so there's a lot of YAML for our data-driven pieces. Recently, we've been moving over to JSON. We found that the community really liked that, and the dynamic ability you have on a system to change things around and test pieces. It has, you know, one of the things that you kind of think about was what is product ready, and I like to think that it means you've basically just got a lot of bugs that you've addressed, right? I mean, we just passed 3,000 out in OpenBMC, out in GitHub last week, so we're getting up there. You know, and a lot of those obviously were features, but there was a lot of bugs too that have been fixed and upstream there. A lot of those, you know, 1% ones that only occur in really certain special situations, especially network ones. They're always the fun ones, but we've got a lot of them out there. We got a lot of them fixed. It's been through a lot of testing. The other cool thing is you know, Brad's mentioned that we do use Yocto, and then BitBake is a part of that. And one of the you know, the cool things about that is you're pulling down all the most recent open source packages. We just got up to the latest Yocto 2.4. It's just got like the latest GCC. So you've just got a distribution here within OpenBMC that's really on those cutting edge pieces. We're working on the 4.13 kernel. We're this close. We're at 4.10 right now. We've been really trying to get into 4.13. And a lot of the problems we've had is kind of what Brad talked about, where we've got our own OpenBMC Linux kernel, and a lot of those patches and pieces that we've put in there to support OpenBMC that haven't been upstreamed cause a lot of pain when you try to move over. But I think we're starting to see that level out, and we definitely have a very strict kernel OpenBMC maintainer that makes sure we don't keep cheating. So lots of good stuff getting upstream. The AST2500 is looking really good. I know we've got Nuvoton now going out on the mailing list, so a couple BMC options if you do want to build a system. Really, really good stuff. All right, systems management. I kind of broke a lot of the rules with PowerPoint charts. I got lots of pictures and text. But from a system management perspective, when we first started OpenBMC, we were kind of lukewarm on IPMI. Really, as the community grew and we realized that there was a lot of people that have written applications and tools that depend on IPMI, you know, we've kind of realized that we really did need to get the full IPMI stack support in place. And so this was a really good collaboration across multiple companies. And really the first quarter of this year, we knocked out most of the IPMI 2.0 stuff, function, along with the DCMI. I was just looking at some notes the other day where people are, we've been just looking for test suites to verify that we have implemented all the IPMI interfaces. And so there's been a lot of neat testing and functions going in that area. And it's looking really good. So IPMI is there, it's out in master. It's got, as we talked, three co-maintainers that keep an eye on all of it. When we first started, we were really focused on a REST API for OpenBMC. So we're kind of lukewarm on IPMI. Redfish, which we'll talk about a little bit later, it wasn't really there. And so what we did is internal to the OpenBMC distribution, the IPC we use is dbus. I don't want to go into too many technical details, but it's a inter-process communication open source package that we use, and it's used in a lot of Linux distributions. And so what we did is we have a GitHub repository, that's the image in the upper right there, where we define the interfaces. All of the dbus interfaces have to be defined out in this repo. It's in a YAML file. There's some magic that happens in that repository when you build OpenBMC that will compile down these YAML files, actually generate C++ code. And those are basically the bindings that you use to implement the interface and then to actually call the interface over dbus. Well, we found this really cool REST server that you could put on top of dbus and would basically just export all of those as REST APIs. And so really, that was and is currently the main mechanism for managing the OpenBMC systems. The cool part is you can do anything through this interface. The not so cool part is, it's just dbus interfaces, and so if you want to change something internally, you start breaking your external REST APIs, which we've had a few vocal people in the community let us know of when we've done that. So, and the other problem is, this isn't a standard, right? I think yesterday at the keynote, they're making a big point on standards, right? And that's really how you get things that can really be rolled out across multiple areas. And so I think we're slowly working on a deprecation of the REST APIs and making it more of a debug. It'll still be there, but no real promises type thing. I think a key piece for us is to get to that Redfish implementation, which is coming soon. I think the cool part from an OpenBMC perspective is there's 4 or 5 implementations out there. There's one in Go, we've got one in Python, we've got one in C++. And so there's been multiple companies that have put them up for comment, that have code to be looking at out in Garrett. And so part of what that work group's trying to do right now is figure out what's the best one, what's the community want to get around here, or maybe a couple. That's another cool thing about OpenBMC. You can pick the one you want. So I'm a firmware engineer, and I know a lot of people here are computer electrical engineers. And so I know in some of the past situations where we've built a web interface for our embedded system, you can tell it was built by a firmware engineer, right? There's always lots of little twisties and drop downs, and you can pretty much do anything you want within that web interface, but it's not always the most user-friendly or usable piece. And so one of the cool things with OpenBMC is we actually had a team within IBM that was really a design team that was really focused on usability and actually talking to customers and seeing how they interact with that web interface and use it. And they actually were the ones that wrote the web UI that's in OpenBMC right now. So it's pretty neat. It's got lots of little options, but not too many. It has all the basic support for firmware update, looking at event logs, checking out the status of your server, obviously powering it on and powering it off. It just recently came in, and it is getting productized, which means there's quite a few bugs coming in right now, but it's looking really good, and I think within the next couple months we'll really get it stabilized and have a good web interface out there to be running in OpenBMC. Another piece, and this is kind of another somewhat non-standard, is we built in this event notification piece. So one of the things that, one of the first systems from IBM's perspective we shipped OpenBMC on was with a HPC contract with the government. It's the Coral contract. And so they're building the next generation high performance computers, and a lot of those from IBM are running OpenBMC. And one of the key pieces in that environment was they needed the ability to not have to poll thousands of BMCs to check temperature sensors and such like that. So we gave the infrastructure in there the ability to subscribe to events. So there's the ability to say, hey, when this processor sensor reaches this temperature threshold, do a callback on this socket. So there is that capability in there. I think as we get SNMP and some of the trap notification abilities in there, that may become another thing that starts to get a little deprecated, but it is there. And then coming soon, Redfish. I think if I just keep talking about it, it'll come sooner, I hope, because I'm really excited to get that into OpenBMC. All right, another very, very important piece is firmware update. And so within OpenBMC, we've basically got two implementations. So I'm kind of trying to talk about both of them here. There's the basic version, which was the first version there, which is basically, here's a flash image, load everything into BMC memory, write that flash image out to the flash chip, and reboot the thing and hope for the best. And so that's kind of the JFFS2 implementation that's out there now. At IBM, we realized that just didn't meet some of the characteristics that we needed for our systems, and so we designed this second code update implementation, which it uses the UBI file system, which just had some natural functions that we liked to be able to resize the partitions a bit. It's got really good wear leveling inside of it. And then we actually have the host firmware in its own flash chip that the BMC manages. And we were able to use the UBI file system over that as well, which had some neat capabilities when it came to looking at specific partitions of the host and clearing some of the data that they write during certain factory resets and stuff. Both of the code update implementations have TFTP. You can just SCP the image over and run some scripts, or there's also a REST API to put them over there. The UBI one is the only one that has a really multi-image support, where you could have multiple BMC images and choose one to activate. For the implementation on our server, we just basically had two flash chips. And so when you do a code update, it writes the other one, updates some U-boot variables, and boots over to it. And another advantage of having those two images is some of this brick protection support, where if there does end up being a corruption or a problem with the code update, you can configure the BMC hardware to automatically fail back over to the other flash chip. So trying to get in those situations, which we all hate, where you can't get into your BMC to debug what's going on. We also just rolled out signed image support. So when you build an OpenBMC image out of GitHub, I think what happens is it uses just a default key to sign the image. But basically, there's a capability to override that with your own private key when you're building an image internally. And then the OpenBMC firmware, when you upload the images, will check with the public keys that it has stored inside of it to make sure that the image you're trying to write is good. And this is kind of a first step in our path of getting a little bit more secure within OpenBMC. It's definitely an area that we know we need to improve. So yeah, that's firmware update and the way pieces work there. Configuration and control. So this is a variety of items, really, but they're all useful pieces for different environments and different people. We've got the network stack within OpenBMC, your static IP, your DHCP. It's got VLAN capabilities. We've got a pretty advanced time capabilities where you can make it BMC controlled, you can make it host controlled, you can have both of them control it, you can split it. Manual mode, you've got NTP capabilities. Really went to town on the Phosphor Time Manager. You got remote host consoles, so you've got an ability to SSH in. You can go over IPMI to get into your system and then get the host control capabilities. It's got Avahi and the ZeroConf capabilities. It's got an event logs built into it. I think that was the picture. No, that was a sensor picture that we're looking at. So the event logs within OpenBMC are something that are a little complex, and I think we're working at finding ways to improve it. We've also are working on, and it's out on the mailing list, a capability where companies or people building systems can customize the event logs. It's, especially within IBM, the event logs are used a lot and very important when it comes to the serviceability of it. So we're looking at ways that we can kind of plug and play, where you've got kind of a default event log. But these are all defined as YAML files. They get compiled down. OpenBMC is an exception-enabled system, which, you know, there's two sides of the story on that one with everybody, but it was a decision that we made. And so these event logs are actually propagated as exceptions, which can get caught, committed, and then viewed with the event log capabilities on the system. Of course, the BMC's got to have power and cooling management. There's you know, some pretty advanced fan control algorithms out there. I think we've got a new one coming in currently. And then the general ability to power on your systems. I think that was, we were talking a little bit earlier about the system state piece, which is actually just built on systemd. One of the other mantras of OpenBMC is definitely using any open source packages that are available. And a part of that design was, you know, there's a target that says this is what you start to power on your system. But then obviously it's going to be very different from system to system and the things you're working on. And so one of the key pieces is within the bitbake recipes and layers, that's where you put in your custom ability to, this is how you really power on the system. And that's what you see in kind of the power targeting. So there's a basic infrastructure for, this is how you power on, this is how you power off, this is the chassis, power on, this is the host target to start the system. And then you as a user come in and fill those in if the defaults aren't what you need. And then last, I mentioned that we've got QEMU, which is an emulator/simulator that supports OpenBMC. We've actually got our own QEMU branch or fork within OpenBMC where we've added support for a few of our systems. There's kind of a default QEMU that supports a very basic image that you can build in OpenBMC. But we got a lot of value out of being able to build our actual system image and then running it in QEMU. And obviously you can't really power on the system or boot a host, but you can start all the applications that you need to start to get to the ready state, and you can test all the different pieces in that state on the system. One of my jobs is to manage the hardware CI. So whenever somebody submits code up into the OpenBMC project, it gets built by an external Jenkins. And then we've got actually an internal Jenkins that will take that image and put it on, flash it on real hardware, and verify, you know, obviously just a CI job that verifies it still boots and nothing's bad. But when somebody puts up a really bad image, especially when we were going through the code update pieces, it can get pretty horrible to fix that hardware. So one of the neat things about QEMU is you can kind of give it that sanity check to make sure it still boots and such to the ready state. And then coming soon, and I got a good old Uncle Sam here saying we're always interested in help, and I think, you know, there's a lot of neat pieces going out there with all these topics. VGA mirroring, I don't know how important that is to people, but for our group, one of the things people need to be able to do is roll a crash card up to a system with just a VGA monitor and get the host output to see where there's problems. So we've got the LTC team, the kernel team working on that. It's mostly kernel work for that piece. Redfish, mentioning it again, we're definitely gonna get it. User management, we really have one ID right now, right, and it's root. And so we're definitely working on getting some more capabilities in that area. Love to see some LDAP and some abilities for you to pick different users that are non-root to run in there. KVM over IP, that's another area we're interested in getting, just more management and interacting with the host piece. Remote media, which kind of goes along with the KVM piece, the ability to plug in some different devices there. We're working on SNMP. Really would like to get that. It's been pretty clear to us that is an important feature for the community and different customers. Telemetry, which is always it's a very broad topic. You know, we've already got pieces of telemetry within OpenBMC, but there's a lot of different views on outputting a ton of data and then having something do the back-end processing of that data versus, oh, we want the BMC to collect the average temperature of these processors for a day and then be able to export it. So there's a lot of mails out on the mailing list in this area, but we're definitely peeling the onion on those types of pieces. In-band firmware update. Right now it's all out of band, so we definitely want to look at this next as a way to just be able to do code updates from the host. I think there's already some code out there, right, that has an example of how to do it over IPMI. So definitely looking at that as a community and something we'd really like to get mainlined out there. And then just the security pieces. The last time we had a hackathon a couple months ago as an OpenBMC group, and one of the things we were talking about was, getting SC Linux in there, getting some policies around our stuff, not running all of the applications as root. We've made a pretty strong effort to get rid of all of our Python applications out of OpenBMC. You know, initially a lot of the prototyping and work that we did at the beginning, it was really easy to get together, get a lot of Python applications out to fulfill the interfaces, but we've been slowly replacing those with C++ code and using some of the new SD-Bus Plus functionality and such. And so, you know, part of that security, there's not just one piece, there's a lot of little pieces that we really want to start improving on in OpenBMC. That's it. Any questions?
Nope.
All right.
Okay.
Thank you.
Thanks, Andrew.